I wanted to give a little bit of a historical picture of how artemisinin resistance was detected and how was the reaction of different stakeholders, the programs, the donors, the researchers, WHO. And I leave the very complicated part of molecular markers and discovery and research to Chris, as it's quite a complicated part. First of all, the artemisinin resistance is quite an old story. It was detected, in fact, in 2001 in Pailin by a routine surveillance conducted by the National Malaria Control Program. And this raised different comments. First of all, I mean, the importance of having a good a strong national malaria control program, able to do surveillance, good quality surveillance. I'm not only talking about drug efficacy testing, but all kinds of surveillance regarding the malaria. This was extremely important. To say that at the time when these data were reported, the scientific community was quite skeptical because some people said we will never see artemisinin resistance over the next 100 years. So, the malaria, it was quite not well perceived, and despite the very hard work done by the National Malaria Control Program. Then there is also a big role by the researcher, because when this data came out, in fact, nobody trusts them, and it's only when AFRIMS, some years later, published the same data in the same area, Pailin, Tassan, which are not very far away, then definitely the scientific community accepted to say there is a problem with the artemisinin resistance. And then coming a third player, which are the donors. And here we have a very, very quick reaction from the Bill and Melinda Gates Foundation, who said we need absolutely to know what is going on, and they immediately funded a consortium which was called ARC3, which was coordinated by WHO. And thanks to this coordination effort, we finally managed to really confirm the emergence of artemisinin resistance, which is translated as delayed clearance. Here also, the researchers played an enormous role, because to confirm artemisinin resistance, we needed to do very sophisticated study. Chris was part of it. It was not simple. The National Malaria Control Program were part of it, but definitely we needed the support of research institutes. Then we entered into a new era, which is the containment effort. Here also a very quick reaction from the Bill and Melinda Gates Foundation, also support from the USAID, who was present in the Mekong since many years. And what people must understand, that in the past, when we were facing chloroquine resistance, we shift to SP. When we were facing SP resistance, we shift to mefloquine. But there was never an attempt, a real effort to try to do something to stop the spread of any kind of resistance. And you can see this today with antibiotics. I mean, people are facing the same problem. So we tried to do the first effort of containing something which was quite difficult to contain, I must say. And what happened is that it was a kind of booster to the National Malaria Control Program with a lot of investment. We had early detection and treatment. We had 7 days, 24 hours health system open. We strengthened the village health worker system. We trained more than 2,000 workers in the Pailin area. We also worked with other non-health agency, like the police, for instance, the justice in Cambodia. They were able to have, they created a justice police. People went to the shops, took the fake drugs, tried to replace the monotherapy with ACTs. I mean, there was a lot of activity going on. And here again, the very crucial role of a very strong national malaria control program supported by partners, and partners working in order to support the program. What was the result? The result was definitely, people can argue that we failed in containment, but definitely the result was a massive reduction of burden of malaria in this region. Unfortunately, there are still cases there. This cannot be denied, and the problem was that among these parasites, you have 90% of these parasites that are artemisinin resistant. So in one way, it was a success. In another way, we selected the most resistant parasite. Then, of course, since this was a kind of success, I mean, we tried to translate this in other parts of the world, like in Myanmar. We created the MARC, the Myanmar artemisinin resistance containment activities. We also went to Vietnam. We tried to do it, but all this was a kind of patchy, was not very well coordinated. That's why WHO entered and developed the ERA framework, the Emergency Response to Artemisinin Resistance, which had the mandate to have a more coordinated, to have more cross-border, to have a more regional perspective compared to country-by-country activities. So this effort also was supported very quickly by the Gates Foundation and by the Australian, and also PMI and USAID are playing a role there. This led, in fact, to increase the surveillance. And when you increase surveillance, of course, you see more things, more problems, and that's not necessarily because we failed, but it's also because we look better. And here again, the last point I would like to raise is the role that played the researcher. If you look how it went with chloroquine, it took 2 decades to find the gene of resistance of chloroquine. If you look how quickly the researcher detected the K13 gene, I mean, it's amazing, and this was quite a revolution in the way we could do surveillance of artemisinin resistance in the area. So there was, based on this new surveillance system, in fact, we had good and bad news. Chris will talk about the good or bad news. It was, in fact, it was not only spreading, it was also popping up like mushrooms, but at least we know where we are. And other bad news is that we also discovered that in addition to the artemisinin resistance, now we are facing another problems, even maybe a greater problems, which is the multi-drug resistance, because you have some part at the border between Cambodia and Thailand where malaria is quite untreatable, where you have every drug which is failing, which is quite a problem. So having the fact that we have artemisinin resistance in the area, having the fact that we have multi-drug resistance in some part at the border between Thailand and Cambodia, and because, thanks to the containment effort, the burden of disease was never so low than we ever had seen it over the last 20 years, that in fact it's a great momentum to start and to think about the elimination of malaria in the greater Mekong subregion. So this part, we are currently working on it. The ERA, which is a framework between going from 2013 to 2015, will be replaced by elimination strategy. We hope that this will be launched before the end of 2015, of course, but we are working on getting this strategy. You know, it's a little bit complicated because this is a policy for WHO, so we have to go through the global technical strategy, we have to go through the executive board and then to the World Health Assembly, but the elimination in the greater Mekong subregion is very well listed in the global technical strategy, and I'm quite sure that the ERA will take on board this elimination, and we hope we will be successful in until 2030 with the goal of eliminating malaria with prioritizing falciparum. But as we know, once you have eliminated falciparum, the vivax is in a period of 2 to 5 years, you also are able to eliminate vivax malaria. This is Greater Mekong subregion. Just one word that we do not forget other parts of the world, South America, Africa. We are also working with our regional offices in PAU and in AFRO, not to have an emergency plan, but at least to be prepared and try to avoid the emergence of artemisinin resistance in South America. The news are quite good. We do not find, for the time being, the K13. In Africa, it's another problem. Chris will talk about this. But at least we are going to prepare in order to avoid the emergence of artemisinin resistance. And if it emerges, these two regions must be prepared to be able to contain and, if possible, eliminate where feasible. Thank you.
Thanks, Pascal. Chris?
Thanks. So the Ebola epidemic has taught me that fear is a great motivator. And one thing that I'm very afraid of right now is the specter of untreatable malaria. People who were in Southeast Asia on the Thai-Myanmar border, Thai-Cambodian border in the 1980s saw truly untreatable malaria, where a pregnant woman would come in with malaria and give the drugs, repeat the drugs, nothing worked, and people died. I haven't seen that, but what I've seen in Africa in the 1990s was where we didn't have drugs that could treat so-called uncomplicated malaria or mild malaria. So kids would be out in the community, they would get chloroquine, they would get sulfadoxine-pyrimethamine, the first-line drugs. They would not respond. They would come into the hospital, and we saw many, many cases of severe malaria, children coming in coma with severe anemia, and at least we had drugs then to treat the severe malaria that were working. With ACT resistance, the same drugs, the artemisinin that we use for uncomplicated malaria, are the drugs we rely on now for severe malaria throughout most of the world. So we really are facing the potential of truly untreatable malaria now that we're beginning to see the partner drugs in ACTs. When the parasite is resistant to both the partner drug and the artemisinin, then you start to see the treatment failure. And I've seen reports of up to 40 or higher percent true clinical treatment failures to ACTs in Western Cambodia. So that is very scary. In order to be able to manage and respond to, contain or eliminate resistance, we need to be able to map it. We need to know the distribution. We need to know the prevalence. Normally, the way we do that is by doing clinical trials where we have to enroll patients who come in sick with malaria one by one, get informed consent, draw samples, start a treatment regimen, treat them for 3 days or 5 days, and then follow them for at least a few weeks. And especially in places where malaria incidence is getting quite low, as it is in Western Cambodia and other places where resistance has been a concern, that can take 2 years to get even a sample size of 60 for one of these studies to give you a percent, a number of how much resistance there is. So this study is the so-called TRACK study, the Tracking Resistance to Artemisinin Collaboration, just published earlier this year in the New England Journal of Medicine. That started out as a big multi-center clinical trial looking all around the region as well as a couple sites in Africa to try to get the most up-to-date map as possible of the current status of artemisinin resistance. During the course of that trial, this famous K13 gene that Pascal talks about was discovered. It just refers to the name of the gene in the chromosome 13, K13. So the same way that drug-resistant cancer or drug-resistant viruses or bacteria become resistant when there's a genetic mutation in a particular gene, the same thing is true in malaria. And so it took some studies, genome-wide association studies to find this gene. And now we have the ability, instead of waiting for a year or two to enroll clinical cases of malaria, do clinical trials, and find out how much resistance there is in one place or another, we can do a finger prick, take a few drops of blood, put it on a piece of paper, take it to labs. Virtually any country where there's malaria has a lab that they can do much of this work and get the sequence of this gene and be able to map malaria. So this shows you, the pie graphs show you the dark color is basically the prevalence of artemisinin resistance based on a combination of clinical and molecular surveillance data. So you can see the distribution centers with the highest prevalence rates right around Western Cambodia, the Thailand-Cambodia border, but now moving into Myanmar. So this was based on data collected in the last couple of years and just published this year. And just a few weeks ago at the American Society of Tropical Medicine and Hygiene meeting, Charlie Woodrow from Mahidol Oxford University in Thailand showed these two maps. So the one on the left is based on the prevalence of K13, sequencing this new molecular marker of artemisinin resistance. And basically, you can see the darker, more reddish colors indicate higher prevalence of the resistance gene, and then the blue is the lowest prevalence down to 0. And this is just Myanmar here. This is the only country that is mapped at this point using this approach. And it looks as if the resistance is most prominent on the right-hand side along the border of Myanmar with Thailand, as if there's a wave of resistance coming from Cambodia and reaching Burma, and you might imagine that change of color down the center of the country is sort of the frontier of resistance. And that's how we'd been thinking about it based on how resistance has behaved for every other drug in malaria. Chloroquine resistance, other forms of resistance started in this part of the world and spread, eventually got to India and then to Africa and had catastrophic consequences. Some of our molecular work, though, is telling us that it's not quite so simple. So I won't go into the details of how we do it, but looking at genes upstream and downstream on the parasite chromosome from the resistance gene, we can do what amounts to a paternity test. So we see the same resistance mutation popping up in Cambodia, and that same thing pops up in Myanmar. It seems likely that it's spread. But by doing this so-called paternity test, we can say, well, actually, it's the same mutation, but it's coming up on a different ancestral lineage. It's a different parent, so it came up independently. So that's what Pascal's referring to. It's both spreading contiguously, but also popping up independently multiple times in multiple places. And there's 2 papers coming out this week in Science magazine that go into much more detail on understanding this, the molecular basis of this. And it's possible that there's a strain or something like a strain that spreads and then different mutations pop up on that background, but it's also clear that you can have resistance popping up. Why do I go on at such length about this kind of popping and jumping resistance? Well, it has major implications for how we deal with resistance. Up until quite recently, we'd been thinking we should try to contain resistance. We can put up a firewall, we'll block it, it won't get past that, we'll prevent it from getting to India and to Africa and beyond. If it can come up independently, we can't necessarily do that, right? So the thinking now, which has not yet been endorsed by WHO, but there's, I think, a consensus emerging, is that we have to simply eliminate malaria from the entire region. We can't hope to contain it. There may still be some sense in which we could delay the spread of a sort of mutagenic strain, a strain that's more prone to resistance. And there's research that will help us to understand that. But really, the evidence is, I think, forcing us to acknowledge that we simply have to eliminate falciparum malaria from the whole region. And so that's the hope. I show up this other map here on the right. This is an uncertainty map. So again, the reddish and yellowish tells us we have more confidence based on how much sampling has been done. We have more confidence in our estimates of the prevalence of resistance on the Thailand, China, and Thailand, and Myanmar, China, and Myanmar, Thailand borders. But you can see that the same blue areas on the left, where it seems like there's virtually no resistance, there's also a lot of blue on the right telling us we have very little data from that area. That's Rakhine State in western Myanmar. Also not so much data from the India-Myanmar border, Chin State. So this is up here to show you that we really, now that we have the tools, we need to deploy them. There's very few sentinel sites where samples are being done, where the clinical trials that Pascal has described have been done over the years. Now with this new tool, we have the ability to go out and get very simple samples collected, just a drop of blood from a finger or an earlobe prick, and take those back to a lab, the civilian lab in Yangon, Myanmar, labs in Phnom Penh and so forth. The military lab in Naypyidaw, Myanmar has tremendous capability for doing molecular surveillance. That kind of work not only will help us populate the map and guide our malaria elimination efforts, but it's also another great way to build political will and get country buy-in.
Thanks. Before we turn over to insecticide resistance, I wonder, both of you probably have a good perspective on this. First of all, Pascal, it's your job at GMP to sort of track progress countries are making in monitoring for anti-malarial drug resistance. And Chris, you've had an important role in helping convene the Worldwide Anti-Malarial Resistance Network. Collectively, how confident are you that outside of the Southeast Asia region, we have the resources deployed to be able to track resistant malaria?
Well, a lot of the work that I've shown you and a lot of the evidence that Pascal has for WHO comes from academic groups. Mm-hmm. And so the truth is it's kind of patchy. The National Malaria Control Programs, the academic groups, many, if not most of us, do share our data with WHO, and Pascal can comment more on this. Mm-hmm. But the fact is that we're not really systematic about it. We can't necessarily count on data being generated in the places where it's needed most, where there are the least resources, the civil unrest and so forth. Central Africa comes to mind, some of the border areas, the border of Myanmar and India, the China-Myanmar border, where there are conflict areas that are not under the control of the Ministry of Health or even accessible to the military. So to the extent that we can have, for example, some of the geosentinel capabilities of our militaries get involved and help us cover these areas, I think there's a lot of room for having more comprehensive coverage and getting into areas where the data are really pretty thin right now.
I think we have limitation. I mean, the gold standard is still the therapeutic efficacy testing, which we try to deploy as much as possible, and we increase the number of countries that are doing TES over the last years. There are countries that cannot do a therapeutic efficacy because, as mentioned, you need a number of patients. So, but among the country able, we have 75% of the countries that have conducted over the last 2 years a therapeutic efficacy study. So, I mean, we cover quite well. Now, this could be simplified if we would have molecular markers, and unfortunately, now we have the molecular marker for artemisinin resistance, but we do not have molecular markers for all the partner drugs. This would be a very useful tool as an early warning system, though there is not always a good correlation between molecular markers and in clinical trials, but nevertheless, it's an excellent early warning system to see when a problem is emerging. So I think we need to continue doing the gold standards. We need to continue to use a standardized protocol to do monitoring. We need to develop new tools, new markers for the new drugs coming. And I think we should combine both. And it's very easy with a simple filter paper. You can easily draw these maps. And one of our tasks is to try to collect. One of the bottlenecks is, as Chris said, I mean, researchers are sometimes very keen to share, but there are still some that do not want to share until publication, which is a huge problem. I mean, it was quite complicated to have this data, but we got it thanks to Chris.
Okay. Thank you both. I want to ask everybody to literally turn their attention to our colleagues from East and West Africa to address the issue of insecticide resistance and how that's shaping up and shapes our perspective in moving forward.
Thank you.
Martin?
I would like to speak about some practical approach to reduce the spread of vector resistance to insecticides in Africa. Vector resistance is not a new phenomenon. It was reported for the first time in Africa in 1960, but at this time it was limited to just a few West African countries, to only one class of insecticide, but currently it is extended to all countries, to the major malaria vectors, and covers all family of insecticides, particularly in West Africa, where the situation is very serious. One of the consequences of vector resistance is the decrease of the effectiveness of long-lasting nets and indoor residual spraying. The problem today, what should we do then in such a situation? Sit back and wait for the development of new products with a new mode of action? I don't think. While awaiting the development of a new class of insecticides, a series of actions could be taken to manage vector resistance in order to mitigate the spread. The first action concerns the countries, African countries, and particularly the National Malaria Control Program. The first point is yearly monitoring of vector resistance at the national level and mapping of vector resistance. Once the mapping achieved, monitoring evolution of vector resistance in sentinel sites selected in various ecological areas and not not a political viewpoint. If resistance detected, determine the mechanism used by mosquitoes to resist. In case of lack of skills, request African Network on Vector Resistance Technical Assistance for Capacity Building. Once this information is available, use a strategy to delay the emergence of vector resistance. The principle is clear. Avoid to expose mosquitoes to the same insecticide for a long time. Then different potential methods could be used. Different class of insecticides could be sprayed in rotation every year or every 2 years. In case of high vector resistance to pyrethroids, we can try carbamate or organophosphates indoor residual spraying inserted between long-lasting net distribution campaign. We can also try combination of carbamate or organophosphate indoor residual spraying plus long-lasting net in the same house in case of high malaria transmission. The second point, the second action concerns the manufacturers. Continuing enhancing the formulation of available insecticides like mixture of insecticides of different mode of action, development of long-lasting nets with synergists, and also developing new class of insecticides. The last action concerns partners, providing African Network on Vector Resistance with support to help countries in achieving vector resistance management, vector resistance mapping. The last point, supporting 3 or 4 vector resistance management studies in countries involved in PMI, indoor residual spraying program. Thank you.
Thank you, Martin. Fredros?
Thanks, Patrick. You realize it's close to midnight at home. So
Yeah.
if you see me dozing, just punch me in the face. This is good. Yeah, so my colleagues, I think it's important that when we talk about insecticide resistance, we have to be careful enough that we do not paint a picture of failure. Because, I mean, having all these said, we have to realize that in the past few years, at least since I was born, there has been tremendous achievement. And I think the global community has made a lot of gains with regard to malaria. And all these were happening at a time when resistance records were also rising. So we've got to be careful enough to always remember that despite the challenges that insecticide resistance and drug resistance face, there's still room to make a lot of gains. And this has happened. We must, however, move further to ensure that the gains that are being made are not lost. And I think at the stage that we are today, there's also an ethical issue about whether we should go forward with malaria elimination. Because at this stage, if we don't, what is likely to happen might be more difficult to deal with than the stage where we were before. If we let resistance result into resurgence, the situation might be a lot more difficult than we currently have. So I think we've gotten ourselves into a quagmire kind of situation, in a catch-22 kind of situation, where we can't let go. We have to just continue until we get to zero. So this is the first point that I wanted to make. The second point that I wanted to make is that a lot of people are also still looking for evidence that actually resistance does cause problems to control. does insecticide resistance, affect malaria vector prevention in any way? And I think a lot of data exists now that at least for indoor residual spraying, IRS, it is important to have insecticides against which the mosquitoes are susceptible. We have very weak data to suggest that bed nets can be affected, but of course, in the olden days when bed nets were still not long-lasting type, this was an issue. You needed to make sure that your bed nets make intact. What we have to realize now, however, is that if you sleep under an intact bed net, the mosquitoes will not bite you. So this is a fact of the matter. So the point I'm trying to raise is that bed nets, which are our best tools today, remain effective despite the spread of insecticide resistance of any form. And so we've got to realize that we must not stop doing what we're doing just because resistance is there. We have to continue, and of course, we have to get add-on tools that will fill these gaps. But the thing that we're facing now is a gap rather than a failure. This is important to address. The third thing that I wanted to talk about is the differences between, in entomology, we like to refer to them as physiological resistance versus behavioral resistance. And I think for a lot of people, when we say resistance, we basically just mean that the mosquitoes are not dying. Now, this is right. But we have to realize that we also have a lot of evidence now that even when the mosquitoes don't make contact with these prevention tools, they can avoid these tools. And that we have a lot of mosquitoes that now bite you before the time that you'd normally be using your bed net. We also have mosquitoes that bite you outside your house. So these are the mosquitoes that contribute most to residual malaria transmission in the places where I live and also in the Southeast Asia. Now remember that if you wanted to use a bed net, and if you want to evaluate a bed net, you must not say that the bed nets have failed just because they didn't kill the mosquitoes that were biting people when the people were outdoors. Because I think we are creating an over expectation sort of. We are judging bed nets too tough. We expect bed nets to do things that they wouldn't do anyway. We expect bed nets to kill mosquitoes that bite you when you're cooking outdoors, when this really can't happen. I think the things that bed nets can do, bed nets have done that really well, and we've got to give them credit for that. As someone talked earlier and said, we have now a lot of projects that are trying to develop new tools that could be used outside the house, or those that could be used before the time that you'd normally go under your bed net. For example, repellents, for example, odor-baited technologies that we're working on in Ifakara. We have a fantastic new tool now that attracts and kills mosquitoes when you are outside your house. We have spatial repellents that prevent mosquitoes from entering a large area. And all these things we expect will be used in addition to bed nets and therefore be able to reduce malaria towards the thresholds that we require for elimination. Lastly, Patrick, I think we have to also realize that as the malaria community and maybe as the overall global health community, we have been sleeping on the job for quite a while. Innovation has been very limited. In fact, to say the truth, some of the best tools that we have today are also the oldest tools that we have in malaria control. And I'm very happy today to listen to speakers who remind us that at least for the past 5 years, we now have a pipeline of new tools. But if you look at the drugs, artemisinin, for this thing has been used for 2,000 years, my friends. So why have other sectors developed so fast when the global health community didn't? Queen Cleopatra slept under bed nets. Many, many years, people have used bed nets. It's still the best tool we have today. Quinine, there was a Peruvian lady here today. You guys have used these things for 300 years. It is still our second best medicine we have today. So you see that there's been actually very little innovation and therefore a lot of room to engage everyone else, not only those people working on the health sector, to engage a lot of people to get new tools that could be used in addition to the best ones that we have today to create the next generation of interventions, which together with bed nets and with indoor residual spraying will go after the challenges that we refer to today, including insecticide resistance. Even on bed nets alone, there's still a lot of room for innovation. Patrick, I think that's all I should say for now. We could engage a lot more later.
Right. Well, thanks both of you. Maybe before we open it for comments and input from the floor, I'd like to ask both of you to consider briefly, we heard some earlier today about the relative size of the investments in the public health application of insecticides and the agricultural market for insecticides, the pressure to develop new actives and the pressures to deploy. Can both of you comment a little bit on to what extent the use of insecticides in the agricultural sector is contributing and shaping the patterns in insecticide resistance we see, specifically to the insecticide classes we use for public health? And maybe thinking ahead, looking at some of the innovations you described, Fredros, and some of the strategies that Martin described for mitigation or containment, how can the agriculture sector be incorporated into our plans for being good stewards of the insecticide products we have for public health?
Insecticide resistance.
Mm.
What I know, West Africa is the region of the highest development of cotton. And I think this is why the resistance is very high in West Africa. You can't produce cotton without using massive use of agricultural insecticides against cotton pests. I think the first reason of this highest vector resistance in Africa is due to the use of agricultural insecticides. I know also that West Africa is the region where vector resistance is well documented due to the presence of some research institutions involved in vector control research, like CREC in Benin, MRTC in Mali, Goods Institution in Senegal, and in Côte d'Ivoire. In West Africa, resistance is high, but it is well documented. In the other countries, I'm sure resistance is also high, but not well documented because of lack of skills. There are also some countries who are in some contexts, some countries who were in war for a long time, like Liberia, like Senegal, like RDC, Congo, Sierra Leone, Guinea, Equatorial Guinea, Conakry. They spent all time in the war, and they don't have time to do research and so on. The emergence of the resistance is not, I think, due particularly to insecticide used in public health. I don't think, because public health use very little insecticide. I don't know if
Yeah,
it's okay.
I think so. Maybe, Fred, if you could target your response to how we might involve the agriculture sector in some of the solutions.
Right. First I wanted to say that I think the issue of agriculture here, it's both a blessing and what, if not properly managed, can be a disaster. In the sense that I think the agricultural sector, given the financial incentives, has made some very big leaps in the past century. And this allows the public health community to leapfrog. We don't have to start everything from scratch. And I know through the work that the IVCC group are doing, it's now possible for them to go straight to the agricultural sector, pick up a formula, reformulate it, and make it available for public health without having to reinvent to try to discover new actives. These opportunities exist because of the financial incentives that the agricultural sector had. But of course, and WHO says clearly now that we've got to involve judicious, what they refer to as judicious use of the available insecticides. And this means simply that if you have to use an insecticide to control any disease, you've got to target it and make sure that it is only going where it's supposed to go, which is a lot more difficult to do with the agricultural sector. And so this fight as to what is the source or what is the biggest reason that we have resistance is going to continue, but I think the onus is on both the people spraying insecticides for agricultural use and the people spraying it indoors to just make sure that it is being used the correct way and that it's monitored. Now, you also asked me to check whether we can learn from some of these technologies that have been used. There is now a limited but a growing interest on how we can use things such as space spraying, which was for a long time used in the agricultural sector against herbicides, on crushing mosquito populations. And I think this is important path to trial, but of course we have to be worried about whether this is going to increase resistance as such. So again, for me, I see this as an opportunity for the agricultural sector to collaborate more with the public health sector and not say this is, for the health minister to deal with and this is for the Ministry of Agriculture to deal with. These guys have to somehow work together, not only to share data, but also to monitor what's happening with their interventions. Yeah.
Great. Yes.
I want to add a point. What are we doing now in Africa? Face vector resistance. I think this is important. There are many actions. The first is the political will. Surveillance of vector resistance in some countries, like my country, Benin, is an important component of the work plan of the Ministry of Health against mosquitoes. Another point is in Africa, we have created INVR. INVR is African Network on Malaria, African Network on Vector Resistance. It was created in the year 2000 by WHO EFRO. And NVA regroup all entomology researchers working on vector control, all national malaria control programs, and all university and research institution involved in vector control research. And the goal of NVR is to ensure safe and judicious use of insecticides in Africa. The second goal is to help national malaria control programs in terms of capacity building, training, helping the national malaria control program for insecticides, for insecticide testing,
Right.
to help them to implement a strategy of vector resistance. Another point is the global plan for insecticide resistant management elaborated. This plan is elaborated and it's based on rotation of insecticides, but it is very difficult to implement what is proposed in this plan.
I think you bring up a really important parallel between the resistance discussions for drugs or insecticides, and that's the importance of global plans, as well as networks of researchers and programmers, program managers that work on these issues. Wonder if we can take the remaining time now to open the floor to questions or comments from the audience, issues you want the panel to address. Steve?
So Pascal, as you pointed out in your presentation, if you wanted to select for artemisinin resistance, then the way you went about treating artemisinin resistance was the way to go, right?
Sorry, if
So if you have a parasite that's resistant to a drug and at a low level, and then the drug is pretty effective otherwise, and then you go use that drug, then that's the best way to select for resistance, right?
yes.
So in retrospect, what would you have done differently, and what drugs are you planning on using for elimination so this won't happen?
Okay. Thank you. Thank you, Steve. First of all, what you have to understand is that currently the artemisinin could be defined as partial, because today the artemisinin, the mutation and everything what we understood about the artemisinin resistance is linked to the ring stage. And we know what's happening. This is what Chris was referring to. The two papers in Science know that now the parasite is slowing down, so the oxidative stress is creating a mechanism that the parasite is really slowing down his metabolism. But if you treat over 7 days, you can overcome this problem. If you have still good partner drugs, you can overcome this delayed clearance. The big issue is that when is going artemisinin to become total, and in this case, even severe malaria will become untreatable, and how quickly are you going to lose the partner drugs? What we see in Cambodia today is that we know that we cannot say that artemisinin has has created piperacillin resistance or mefloquine. Mefloquine resistance was there, but definitely they are linked, they're all related. Okay? So what are the options? You have several options. We can either start to look for a better combination, triple combination, for instance. We can look, for instance, of extended treatment, but this is not exactly what we need for elimination. We need a shorter treatment, not a 5-day regimen, okay? But nevertheless, I mean, if you have untreatable, in some cases, untreatable malaria, maybe we will have to extend the treatment. It's also protecting the partner drugs. Why not in areas like Africa, where you have already ACTs fully effective, no artemisinin resistance, fully effective partner drugs, not adding a third drug. I'm not talking about primaquine to protect this drug in Africa. I mean, there are many things that can be discussed. I mean, but so far, in the greater Mekong-Subrigen, except at the Thai-Cambodian border, the ACTs are fully effective. Delayed clearance, but fully effective, so the drug are still suitable for elimination, but adding low-dose primaquine definitely.
Other contributions, comments back there?
Chris Hockenhouse, Path NVI. I have a question, either Pascal or Chris Plow. It seems to me that the emphasis on the Mekong and the artemisinin resistance was to prevent the spread westward into Bangladesh, India, and then ultimately in Africa. Now, with the emergence of mutations in the K13 in Africa and the burden of disease of falciparum. I mean, falciparum in Mekong is actually going down, right? And it's Vivax that's coming up. What is being planned to actually address the mutations? I understand fully that it's the delay in clearance isn't being seen in Africa yet. But there is going to be a preponderance of accumulated mutations which may lead to that. What's the WHO plan? Or maybe Chris, you might say, is this something that's arising independently that we should be concerned about? Apart from it's actually going, just like chloroquine or SP from India down into Africa.
So it's hard to answer that without getting kind of deep into the science. So you and I could talk about it later. I don't know if the whole group wants to follow along that conversation. But briefly, what's being seen in Africa right now is very low prevalence. So, 1%, 2%, 2.7% prevalence in a given setting of some mutations in this artemisinin resistance gene, the K13 gene. Many of these mutations are not in the part of the gene that's actually associated with resistance. Some are in that same area, but aren't yet shown to be proven to cause resistance. And what may be happening, we've just submitted some data from Mali showing that 10 or 15 years ago, the same thing was happening, so long before artemisins were used in Mali. So it may be that this is just a gene that has this kind of low-level mutation all the time, but these parasites aren't really ever selected for, as Steve was describing, that even under drug pressure, they don't come and account for 80% of the parasites there. And that could get to do with some of the more complicated genetics where there's a fitness